So far, we discussed the origin of electricity. Now we're going to move on to the next important topic, which means how do you actually charge an object? So there are a variety of ways you actually can charge an object. And this charging itself is also quite complicated. But in this class, we do not require a lot, but you must know how to charge the material. So this is going to be a new slide, and which we're going to show you item 3, charging an object. And so how do you charge an object? There are a couple of ways you could do that. Simply by touching or rubbing, or any kind of things you could do. As far as you're rubbing against each other, and so that will be able to allow you to charge it. And these kind of things in physics we normally not called touching or rubbing, instead which we call contact. So in other words, we normally do not say touching, instead we call contact. So two objects is contact against each other. Second, which is called induction. We talk about it in the Kelvin water dropper. You remember, if you have two objects, and in this case, there's no contact. So the contact between object 1 and object 2 is not there. So this is that's kind of things very, very important. Let me first talk about contact first. So I'm going to sketch a diagram. Suppose I have an object like this, and I have another object, maybe different shape. So they make contact over here. If they rub against each other, so if one material, let's call it material A, it has capability to holding on its charges, and so attract some other charges from object B. So this you can rub it or whatever you do. So as far as you have a charge transfer from object A to object B or the other way around, then you are going to be charge the object. So this is the how do you charge the object? For instance, if you have a negative electron move from A to B, and then A is going to be charged. While induction, there is no contact. Suppose I have similar things like this, A and B. There's no contact physically, A and B. And this is almost exactly the same as we discussed in the Kelvin water dropper. You remember the water is in the center and you have a ring around it. There's no contact, but there is an induction involved. Suppose one object carries positive charge already here, and another object depends on whether you have insulators or conductors. If you have insulators, what will happen is kind of very interesting. Around the surface, did you see here you have a positive charge, so this surface carries the negative charge. Now, adjacent to this, I'm going to zoom this part in over here. So you're going to see like these comes out. It becomes like a pairs. These pairs, which we'll call the dipole, because they're just like these two adjacent to each other. So then you have all these dipoles continuation from all the way to like that. So just continuation. Essentially on this part here, all becomes positively charged, while the left-hand or right-hand side, it becomes a negative charge. And this kind of phenomena, which is called induction. This works very well for insulators. So this works very well for the insulators. And let me give you an example to be more precise what kind of things which we call insulator. So essentially we can talk about what kind of types of charges, what kind of things which we can call insulators: rubber, plastic, dry wood, and paper. These are good insulators. These are good insulators. the wood has to be dry. And if you have a wet, and there won't be called insulator. So these are called insulators. So now next, I'm going to show you what happens if you have a conductor. So I'm going to erase this part now. So remember, this time we zoom. Oh, sorry. Let me undo it. Okay. So if you have a conductor, so then the situation is different. So I'm going to sketch a bottom over here. Suppose this is also my positive B, which is carries charge, and this is my conductor. On the surface, remember, conductor's charge can move easily, freely. So this side will carry positive charge. Inside of it, there will be no charge whatsoever. You only see the positive charge on the left-hand side. So there's no dipole for the conductor anymore. So inside of it, there's no charge. Only on the surface you have charge. And these kind of material are called conductors. Conductors charge can move freely, and insulators you cannot. So that's the core conductor. And I also want to show you what kind of materials are conductors. First, all metals are conductors. And the wet wood, so here I'm going to type this in here. Probably it's easier to read it. So I'm going to write over this side. And wet wood, wood, trees, which means it's living trees, of course, and all metals. And so doesn't matter what kind of you have, all metals and kind of cable, internet cable, all these are good conductors. Now, depends on who you are. If you are young and your skin more or less like moistured, so that's good conductor. The way that you can test it, if you put a finger on the screen, or especially touch screen, if you touch a screen, you can actually maneuver around it. You can use a cell phone touch a screen. So this means your finger is a good conductor. It conducts electricity. On the other hand, if you wear gloves, so whereas some of these gloves may be completely insulating, you can test them. And these gloves are really, really good insulator. If you cannot use it to touch the screen and maybe type some letters. So for instance, if I'm using fingers here, I can move things around. You can see here. So this means my finger is good conductor. So that is the conductor. And sometimes, of course, the air, if you air have a lot of water or rain water inside of it, the air can becomes a good conductor. That's where the lightning occurs. So these are called conductors. Now, something between these conductors and the insulators, and that's another kind of material which we call semiconductors, which I'm going to write over here. Semiconductor. Oh. Semiconductors consist silicon germanium, gallium arsenide, and this is your mouse. So in other words, the mouse, if, for instance, in my mouse, I see the red LED comes out. This is made from the gallium arsenide. These are all semiconductors. Entire semiconductor industry is built on these semiconductors themselves. So in the silicon, you know, soil itself is just made of silicon oxide, a lot of these. So that's why it becomes a very useful compound. It's also abundant like these. So these are three different kinds of material. Once again, I want to emphasize, we have conductors and we have insulators. And so the way that it's charging the material is different. Semiconductors in many ways like insulator, but it's semiconducting. So it becomes very useful. You could use the LED or light emitting diodes or transistors. The entire cell phone made billions of these transistors around it. So they can be used for transistors. And billions, letter B, billions of transistors in your cell phone. So it's a lot, especially nowadays. You can see your cell phone heats up very, very quickly because of this. So this is the how to charge an object. And next, what I'm going to show you is Xerox machine, which is very, very elegant. And so I'm going to stop this recording